Hey Kaylee, got your question regarding taking the second derivative of an implicit equation. To take the second derivative, we have to first take the first derivative, and we're going to differentiate this implicitly. So to do that, we just go ahead and so it'll be 2x plus, and then this guy here, to take the derivative, we do 2y, we differentiate normally, but then we have to do the chain rule. The reason why is because y is a function of x. So we have to tag along a y prime. Or y prime, just so we know, is dy over dx. Okay, so they're the same thing. I'm going to say y prime throughout this problem instead of dy over dx. Equals, and the derivative of 1 is 0. Okay, so now we have to solve for y prime. So then we'll get 2y prime equals negative 2x. Okay, we solve for y prime. We get negative x over y. Okay, so now we have to go further and take the derivative again in order to find the second derivative. So when we take the derivative again, we get y double prime. And then, see, we have x over y, but y is really a function of x. So we have to do the quotient rule. So it'll be the derivative of the top, which is negative 1, times the bottom, which is y, minus the derivative of the bottom, which is 1, but we have to do the chain rule, so it's actually y prime. And then times the top, which is negative x. This will be all over the bottom squared, which is y squared. Okay, let's give us some more room here. So now we're going to simplify this, so it'll be negative y. And then y prime, if we look here, because we don't want y prime in our answer, so y prime is actually equal to this, negative x over y. So we just substitute that in there, and then we have negative x here, and then it's all over y squared. Okay, so then if we simplify this, let's see here, we will get, let's see here, this will end up being negative, so it'll be negative y minus x squared over y all over y squared. Okay, and then notice in our answer, and what they want us to prove here, right here, that there's only y's here. So in other words, we need to get rid of this x squared. Okay, so if we scroll back up, we'll see that x squared, if we look right there, x squared is equal to, I'm going to solve for x squared here. So x squared is going to equal to 1 minus y squared. Okay, and that came from that guy. Okay, so now we can substitute in 1 minus y squared in for this x squared right here. Okay, I'm going to start going right here because I think we're running out of room. So negative y minus 1 minus y squared all over y all over y squared. Okay, and then if we simplify this, I'm going to times this by y over y. So we'll get negative y squared minus 1. I'm going to distribute this negative into both those. So plus y squared all over y all over y squared. I'm going to put that over 1 and then flip and multiply it to the top here. So it'll be times 1 over y squared. Okay. And then we'll get negative y squared plus y squared cancels, and we're left with negative 1 on top. And then if we multiply y times y squared, we get y cubed. All right, so there's our answer. So that equals y double prime, or dy squared over d squared x. So in other words, basically just the second derivative. It's just a fancy way of saying the second derivative. All right, there's our answer. Hope that made sense, Kaylee. Have a good night.